In this video, let's go ahead and talk about how we can find the Laplace inverse of the following. F of s is equal to the quantity 10s plus 26 over s squared plus 4s plus 13. So the first thing I want to do is get this denominator looking like a different form, because s squared plus 4s plus 13 doesn't have any good factorization. So let's go ahead and take these first two terms and use completing the square. So we have s squared plus 4s, and then let's go ahead and half of this squared is 2 squared is 4, and then we're going to subtract 4, and we're still adding that 13. We're subtracting 4, so this is like adding 0, and this will get us s plus 2 quantity squared plus 9, or 9 is also 3 squared. So what we have now is 10s plus 26 over s plus 2 quantity squared plus 3 squared. So this denominator now looks like the form right here for e to the negative at sine omega t, and same thing for e to the negative at cosine of omega t. So that's good. Now we need this numerator to be in the form like s plus a or omega, and we'll actually have both. So what's going to happen is we're going to take out the 10. We get 10 times s plus 2.6. And what we can do is make this equal to 10 times s plus 2 plus 0.6, which is equal to 10 times s plus 2 plus 6. So we get 10 times s plus 2 plus 6 all over the quantity s plus 2 squared plus 3 squared. So then if we separate this into two fractions, we get 10 s plus 2 over s plus 2 quantity squared plus 3 squared plus 6 over s plus 2 squared plus 3 squared. So this is looking very good. So this is very promising. If we take out a 2 on this, we get 2 times 3, and we get 2 times 3 over s plus 2 squared plus 3 squared. And then over here, if we take out the 10 out front, we get 10 times s plus 2 quantity squared over s plus 2 quantity squared plus 3 squared. And now we can easily identify what the Laplace inverse is based on this table. Here we have a is equal to 2, omega equals 3. So for this first one, or for the first one, we have s plus a. So it's e to the negative at cosine omega t, where omega is 3. So we have 10, because it's 10 out front, e to the negative at, so e to the negative 2t times cosine of 3t. And this 3 comes from there. And then we have plus 2 times e to the negative 2t sine of 3t from this one over here. And remember, when we're taking the Laplace inverse, it's a one-sided transform, so we have to use u of t at the end. Awesome. That is our final answer. Let's go ahead and graph that. I went ahead and graphed it. This x greater than 0 is just like saying u of t at the end. We have 10 e to the negative 2x cosine of 3x plus 2 e to the negative 2x sine of 3x. And what we get is some decaying oscillations. The low point here, this is like the overshoot past 0, and then we go up and we overshoot again, and then after that overshoot, it settles pretty quickly down towards 0. So that's a pretty cool looking graph. Nice.